Hey, so hi there folks, we're now in our next video in circles, and we're going to talk about right now more terminologies or more parts of the circle, and specifically we're going to talk about the central angles and the arcs. Okay, so in the rest of this video we're going to be particularly talking about this kind of circle. So in every example, in every illustration that we will be showing, we will go back to this circle here. Okay, so let's define a central angle. Okay, a central angle of a circle is an angle whose vertex is the center of the circle. So imagine an angle. We know an angle is something like this, wherein there are rays. Okay, and this is what we call an angle. So when we say a central angle of one particular circle, so it's a circle wherein the vertex, this one here, this point here, the point wherein the two lines intersect, we call that a vertex, right? Is at the center of a circle. So one instance is angle QPR. Okay, notice angle QPR over here. In this circle, this is angle QPR. So you can imagine this angle over here. So this angle QPR is what we call a central angle because its vertex is on the center of the circle, namely P. Okay, just take note, in many instances, we will not draw anymore the parts of the rays outside the circle because we know traditionally an angle is two rays wherein some parts of the rays, the two rays intersect. So we don't need anymore to write the arrowheads to be exact. Okay, the arrowheads. Okay, so that's what we call a central angle, an angle whose vertex is on the center of the circle. So moving on, let's define what an arc is. So an arc, this is one of unbroken, rather an unbroken part of a circle. So it consists of all the points on the circle. Again, highlighting that. So again, this is outside, this is inside, this is on the circle. Outside the circle, inside the circle, on the circle. So all the points on the circle between and including two given points, between and including two given points. Okay, so these two given points are the endpoints of the arc. Okay, so one example is arc QR. So anyway, we define or we denote arcs with the letters of the endpoints and then with a like an arc above the endpoints. Um, what do you call that? Connecting endpoint to endpoint. So meaning from Q here going to R, our endpoint is Q, our another endpoint is R. So we can imagine, we read this anyway as arc QR, by the way. So arc QR is this. So we have the Q over here, we have the R over here, and this is arc QR. It consists of all the points on the circle. So imagine again, we have a lot of points here on the circle, right? So all the points here between and including these given points. So these two given endpoints are Q and R. So this is the arc of the circle. Okay, the arc QR for this instance. Okay, so that's an example of an arc. So we therefore say that there's a relationship, okay, direct relationship between the central angle and then the arc of a circle. So we say this in this statement first. For every arc on the circle, there corresponds exactly one central angle. Okay, again, for every arc, there is always a corresponding central angle there. So one example is angle QPR corresponds to arc QR. So again, let's see arc QRs over here. There is a corresponding central angle with that. That is angle QPR. And we have this part of the circle. Okay? Actually, if we're going to shade this part of the circle, we call this the sector, a sector of a circle. But that's beyond now as far as our topic is concerned. Okay? So again, an arc, a central angle. Conversely, if every arc on the circle corresponds to exactly one central angle, conversely, we can think of that every central angle corresponds to exactly one arc on the circle. So looking at the same circle over here, okay, we can see that um, angle QPR, again, angle QPR, okay, this angle here, oops, this central angle here, okay, intercepts rather, I'm sorry, intercepts arc QR, as we can see. Okay, it intercepts because again, the concept of angles is that they are raised. So practically this central angle extends, this one also extends. So this central angle intercepts the arc QR. Okay, so we say that central angles intercept the arc. Okay, another example is angle QPT. QPC, this one right here, intercepts arc QT. So arc QT is this one. Okay, so this angle intercepts this arc. Okay, now the measure of an arc, this is one important thing to note. The measure of an arc, the measure of an arc is defined by the measure of the center angle. So that is within which intercepts it. So that is the measure of a random angle xyz is equal to the measure of arc xz. Again, the measure of an angle, a random angle xyz is equal to the measure of the arc xz. Notice the endpoints of this angle. That is as far as circles are concerned and central angles are concerned. Provided this xyz is a central angle, specifically y should be a center of the circle. Okay, so one example will be here. So since QPR, we can see QPR over here. Q Let's make use of another color, shall we? This QPR here, QPR, okay, that's an R. Since QPR is said to be 110, since we can see here 110, therefore the measure of arc QR is also 110. Okay. For example, this let's just say, for example, this angle QPT is, say, let's say this is 120 degrees. How much is the measure of this arc? So no doubt, it's still the same. Arc QT is equal to 120 degrees because it should be equal to the measure of the central angle. Okay, so I hope you learned something from this video. Kindly take hold of the concepts that you have learned here, because we will surely okay use them in the future um, future batch of lessons that we're going to take up in this geometry class, specifically in circles. So that's it. Thank you so much for watching. I hope that you would like and subscribe to my channel. Okay, thank you very much.